Hello students. By this video let us study about the chemical properties of chlorine, that is the bleaching and oxidizing action of chlorine. It comes under the Unit 3 P block elements 2. So first let us see the bleaching action of chlorine. Chlorine is acting as a good bleaching agent. So what is responsible for this strong bleaching action of chlorine is the nascent oxygen. That means atomic oxygen. Oxygen in the atomic form. So that is called as nascent oxygen. So this nascent oxygen is highly reactive. So it is because of this reason chlorine is exhibiting high bleaching action. Okay. So let us look into the reaction here. So chlorine when combines with water, definitely it will form an acid HCl and HOCl. So this we have seen in the previous videos. Whenever chlorine combined with water, you get two products, that is hydrogen and chlorine combined from HCl, and one hydrogen, one oxygen and chlorine combined from HOCl, that is hypochlorous acid. This hypochlorous acid is unstable. So for that reason what happens? It will undergo decomposition. HCl and nascent oxygen, that is the atomic oxygen, single oxygen atom. So because it is nascent oxygen atom, we represent it like this. Put it in the bracket. Okay. So this nascent oxygen is highly reactive. Yes. So what happens when the colored matter or the colored substance, whatever colored substance, okay. So when this colored substance is getting exposed to this nascent oxygen present in the chlorine. Yes. So here colored matter or colored substance, when it is exposed to this, react with this nascent oxygen, oxidation takes place, and this colored matter or the colored substance, it is getting converted into colorless matter. Okay, so whatever color is there for this material or the substance or the matter, so the color is completely lost, it decolorizes. Yes, decolorizes and it becomes completely colorless. And one more thing is that once it is colorless, that color cannot be restored back or regained back. So this type of bleaching action of chlorine is the permanent bleaching. Okay, it's the bleaching effect is permanent here. Okay, so once it is exposed further to the oxygen, further oxidation does not take place and it becomes the permanent colorless. Okay, yes. So now when we compare this bleaching action of chlorine to sulfur dioxide, of course sulfur dioxide is also having the bleaching action. Yes. So there, in the case of sulfur dioxide, bleaching action is not done by oxygen, nascent oxygen. Instead it is nascent hydrogen. Okay. So when the colored matter come across, react with that of the nascent hydrogen, reduction reaction takes place and the colorless matter, that is you get a reduced form of colorless matter. Now this reduced form of colorless matter, when you keep it for a long time, when it stands for some time, what happens? It gets exposed to the oxygen and the colorless matter will regain its color. So that is the temporary bleaching action. Okay. So in the case of sulfur dioxide, the bleaching action is temporary, it is not permanent. But here in the case of chlorine, the bleaching action is permanent. Once it is bleached, then it remains always permanent. Fine, it never regains back its color. Okay, so that is your bleaching action of chlorine. Fine, let us study the oxidizing action of chlorine. Chlorine is a very good oxidizing agent. So what do you mean by oxidizing agent? Oxidizing agent is a substance which can help in oxidation and they themselves get reduced. So by accepting an electron, they themselves get reduced. So generally all halogens, they have the general electronic configuration like Ns2, Np5. So this is the general outer electronic configuration of halogens. So outermost shell 7 electron, Ns2, Np5. So 7 electrons are present in the outermost shell. In order to attain the octet, it requires 1 electron. So for that reason, halogens, they themselves accept an electron, that they get reduced. So this is the oxidizing action of chlorine. Oxidizing action of chlorine in the sense chlorine chlorine can help in oxidation of other substances or other compound, and chlorine they themselves can reduce by accepting an electron. So this is the oxidizing nature of chlorine. Okay. Now let us understand the oxidizing action of chlorine by taking the example of Fe2 plus ion getting converted into Fe3 plus ion. That means ferrous ion, Fe2 plus ion. This is ferrous ion. Ferrous ion is getting oxidized to Fe3 plus ion, that is your ferric ion. So under this we are taking two examples. Yes, that is ferric chloride is obtained from ferrous chloride, and ferrous sulphate is getting oxidized to ferric sulphate. So these two examples we will study. Then the second one is chlorine can undergo act as an oxidizing agent by the sulphide ion is oxidized to sulphate ion. Sulphite ion, that is SO3 2 minus ion, and sulphate ion is SO4 2 minus ion. So understand the difference here. So here also we take the example of sodium sulphite is getting oxidized to sodium sulphate. So that also we will see later on. Then the third oxidizing action of chlorine is that oxidizing hydrogen sulfide to sulfur. So this we have already seen. Since we are studying about the oxidizing action of chlorine, so I just give this example too. Fine. So now first one, let us look into the conversion of ferrous ion, Fe2 plus ion to Fe3 plus ion. So Fe3 plus ion is your ferric ion, and Fe2 plus ion is your ferrous ion. So now okay, we are taking the example of ferrous chloride, FeCl2, ferrous chloride. So in this ferrous chloride, the oxidation state of Fe is +2, so that's why it's ferrous chloride. On reacting with chlorine gas, so chlorine is oxidizing this FeCl2 to FeCl3. So oxidation state of Fe is 3 plus here. So that's why it is ferric chloride. Yes, and this is ferrous chloride. Fine. Now let us balance the reaction here. Here 4 chlorine and here it is 3 chlorine. So to balance, I just put here 2. So when I put here 2, it becomes 6 chlorine. So for that reason, here it is 2 Fe. So I put here 2, it becomes 4 chlorine plus 2 chlorine, 6 chlorine. So chlorine is balanced, and 2 Fe on the left hand side and 2 Fe on the right hand side. So it is balanced. Fine. So that is the conversion of ferrous chloride is oxidized by chlorine to ferric chloride. Fine. Now let us see the conversion of ferrous sulphate to ferric sulphate, Fe2SO4 thrice. So this is ferrous sulphate and this is ferric sulphate. So here, in this case, chlorine gas react with water. So whenever chlorine react with water, it gives a product acid HCl and HOCl. So HOCl is hypochlorous acid. Okay. Now this HOCl react with ferrous sulphate and H2SO4 in the acidic condition, H2SO4 to give Fe2SO4 thrice, that is your ferric sulphate. So along with ferric sulphate, you also get HCl and H2O. So this is the reaction. Yes. Now let us see the overall. Now let us balance the reaction. Here 2 chlorine Here also 2 chlorine, that is balanced. Here 2 hydrogen, that is also balanced. 1 oxygen balanced. Fine. Now here it is 1 Fe, whereas here it is 2 Fe. So to balance, I put here. Yes. Now 2 SO4 and 1 SO4, it becomes 3 SO4, that is balanced. And 1 hydrogen, 1 HCl is 1 HCl, 1 H2 and O combined from H2, so that is also balanced. Fine. Now let us write the overall reaction. Overall reaction here. Yes. So whatever is common, we will just cancel both the sides. Yes. So HOCl will cancel. Then water on the left hand side and another water on the right hand side, that is also cancelled. Yes. So now let us write the overall reaction here. Chlorine gas plus 2 FeSO4 plus H2SO4 gives 2HCl plus Fe2, that is your ferric sulphate. Fe2SO4 thrice. So this is the overall reaction. Yes. So overall reaction is chlorine react with Fe2FeSO4, that is ferrous sulphate, in the presence of H2SO4 to give ferric sulphate Fe2SO4 thrice and 2 HCl. Fine. So that is the oxidizing action of chlorine, oxidizing the ferrous sulphate to ferric sulphate. Fine. Next. Now let us see the second oxidizing action of chlorine, that is converting the sulphides to sulphate. So taking the example of sodium sulphide is getting oxidized due to sodium sulphate. So this reaction let us see now. So first chlorine, as we know, chlorine gas react with water to give HCl and HOCl. HOCl is your hypochlorous acid. Now this HOCl, hypochlorous acid, react with sodium sulphide Na2SO3 to give Na2SO4 and HCl. Yes, so this is the reaction taking place where chlorine is acting as oxidizing agent, oxidizes sodium sulphide to sodium sulphate. Okay, now let us write the overall net reaction. So whatever is common on both the sides, so we will just cancel. Yes, HOCl is cancelled. Yes, now let us write the reaction. So Na2SO3, that is your sodium sulphide, plus chlorine plus water gives Na2SO4, that is your sodium sulphate, plus 2 HCl. So this is the overall reaction of sodium sulphide getting oxidized by the oxidizing action of chlorine to sodium sulphate Na2SO4. Fine. Now let us move to the third reaction, that is H2S2S, that is hydrogen sulfide is oxidized to sulphur. So let us look at that reaction here, the third one. Yes, so H2S, that is hydrogen sulfide, react with chlorine gas to form, that is, it is oxidized to sulphur. Hydrogen sulfide is oxidized to sulphur by the oxidizing action of chlorine. So along with that, we also get 2 HCl. Yes, so this is the oxidizing action of hydrogen sulfide to sulphur. Okay, so that is the oxidizing action of chlorine. So we have taken the 3 examples. For the 3 examples, we have represented with the reactions also. Fine. So that completes your oxidizing action of chlorine. Hope you understood. Thank you.